see if this goes. Check, 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 1, 2. Check, 1, 2. I think we've got it. There we go. I think we do have it here. Yeah, I think we got it. Okay. Check, 1, 2. Audio check. I think we're good. Okay, good morning. Or whatever time zone you're in. So we're just going to do a coding stream, and I asked folks to bring questions. So I know a couple people, I think 2 or 3 people had questions that they wanted to uh, pose. Does anybody who had questions yesterday have those ready? Good morning. Um, yeah, so the question is, just in case the audio is not working, how to code up a moving average as a noob. You're starting off with coding and you're starting off with ACSIL, and you want to do like a simple project, basically, it looks like. It sounds like a first, like a hello world type of project, and where do you start? Um, I think for these types of things, one, it's important to have an idea of what it is you want to actually code, what you do, because you have the moving average idea. And then the next thing is to conceptually understand what makes a moving average. How does this actually, um, how does this actually go about being built? Um, so let's think about that. A moving average is going to be a series of prices that you take an average of, and then that is the value that you end up rendering. So if we draw a chart like this, and we have some candlesticks, and I'll just replicate this. Oh, geez. And let's say we're taking the close price, or yeah, I mean, you have to have either open, high, low, close, one of those. Um, if we were taking the average of the lows, then it would look something like this, right? Somewhere around there. So that's conceptually what we're trying to do. If we're trying to make an average of the highs, it's going to be up there. If we want something that's in the middle, it'll be there. So basically the idea is that we have a series of bars, in this case, candles. We can even, we can do is we can even label them 1, 2, 3. And then what we're trying to derive is actually this point right here. What would be the most recent moving average value based on the last X number of bars? So what are the components? Let's talk about the components of a moving average. Components of a moving average. There's going to be a time period, right? How many bars are you going to look at in order to build your average? And then you're going to have your data set. So what's a common moving average in futures and equities? I know 20 period moving average, 9 period moving average, very common. We have 3 bars drawn here, and I don't feel like drawing 20, so we'll just do a 3 period moving average here. But basically what you need to do in order to make that happen is you need to take the sum of a single point on each of these 3 bars, right? So let's pretend we're doing the lows. We want a moving average of the lows. So you take this value, and this value. You'd sum it up, and then you'd divide it by 3, right? So you have that average formula, that algebraic formula, in order to do it. Now it's all great when we're talking about having it on a canvas here, but what about on the code side, right? Let's go ahead and open up a code editor. I'm gonna prepare a little template here, and I think I even have a template. What is this file? Um, yeah, I don't know when this is from. This is from 2021. Oh, this is from Sierra. This is not even mine. This is from Sierra, I think. It's just called template. Yeah, template.cpp. So if you guys have Sierra chart, you can probably see this as well. This is called template.cpp. I'm going to go ahead and save it as coding stream 5/12/2023.c++, just so that I don't overwrite my template. Um, so basically every Sierra chart custom study starts out with some kind of shell that looks very similar to this. You've got to include the Sierra chart.h. And actually, before we go to that, you said that you didn't have a platform, or you are already doing it in Sierra? You're already using Sierra. Okay. And how familiar are you with C++? Perfect. Okay. So you're gonna in your Sierra chart folder, I think, where is it? It's this guy right here. Um, Sierra chart ACS source. You'll find a file called template, template.cpp. That's the one that I saved and renamed as coding stream. You can open it in any text editor. It doesn't have to be the one that I'm using. You can even use like Notepad if you want, and open it in here. And just to demonstrate that, I will drag that exact same file into here. Notepad is not a great coding editor, so there's a bunch of free ones that you can look to download. Some of them are better than others, but that's probably beyond the scope of this. But if you're looking for one, you can always check out Notepad++. I think is a pretty popular one. Sublime Text is another popular one. These have things like syntax highlighting and can interpret different popular languages like C++ and Python and other stuff. So you might want to take a look at those two free options. I use Vim. It is a very old text editor that is available on pretty much any Unix machine, Linux machine, Mac, uh, going back several decades. So it's just available everywhere, and it allows me to work very quickly, but you don't have to use it. But basically, the top line here, anything with a double slash is a comment, so you can see these are comments. Let me see if I can make this a little bit larger. That's the wrong hotkey. What was the hotkey I programmed for size? There we go. That's easier to see, right? So, um, this is a comment. If I want to write a comment, which is not going to be actually executed by the code, I can put a double slash and say, this won't be executed by my code. Um, this is just a comment to explain stuff. Okay. Um, Here, this line 2, this is showing you that it's going to be including a bunch of functionality that Sierra Chart has exposed for us programmers that we can basically use. All this stuff that we're calling here, all this stuff that we're able to do here and set like graph names and auto looping and inputs and subgraphs. Again, this is part of that template. It's coming to be available to us from here. If we didn't have this, none of these things would exist, if you will, in our code. We wouldn't, when we tried to compile it, it would say, I don't know what the heck an SC is. I don't know what any of this is because we wouldn't have had this. So this is a requirement here. If you want to look at what's in this file, you can also find it. It's in your same exact, it's in here in this directory, and we can even go peek into it. I can split this and go peek into it there. This is that file, crchart.h, and it's got a bunch of stuff in here, several thousand lines. So if you want to do a little light reading, you can come in here and check that out. Anyways, back to our template. More comments. Let's get rid of all these comments. These are noisy. This is the name of the DLL. This is how it's going to show up in your custom, um, in this thing, add custom study list. It's going to show up with this DLL name. So when you click add custom study and then you know, make something, it's going to show up here. So let's go ahead and give this a name of 2023-05-12 coding stream. That'll be the name of our DLL. And then this block right here, which is comprised of this opening squiggly, this closing squiggly. Where's the meeting? It's, oh, he's not in here. It's in, oh, he's not on. Join the coding voice channel. Let me just give him a screenshot. Boom. There you go, bud. So this is our coding block. This is a required piece to declare this function, which will be passed over to Sierra Chart when it needs to execute a study. So just so you understand, when Sierra Chart is executing code, what it's doing is on every single basically tick, it depends on how you have it set up, but basically on every single tick that you have coming through on your symbol. So if you're looking at, I don't know, Apple or Tesla or the ES, what instrument do you trade? Or what's your primary focus instrument? NASDAQ, the NQ? Okay, so you're looking at the NQ and a tick comes in. Sierra Chart will say, if you've added that custom study, Sierra Chart will say, hey, go call that function. Which function? Well, this one right here. Call this function and pass it the data that just came in on that new tick. And then all the stuff between these two squigglies is going to get executed. That's how that works. Inside here, I'm going to rename this. Instead of calling it template function, I'm going to call it our coding stream. And just coming through here to this default section, delete more comments. This default section, this is where if you do have any inputs or subgraphs, you can declare them here. You can give them names. You can give them default values. This is your default code block. I'm going to remove all this stuff for right now. And the graph name, we're going to set this to just be coding stream. This is like the bare minimum stuff here. Okay, so back to moving average as a noob. So we want to, by the way, Sierra already has moving average stuff, so if you do want to do this without coding, I think you can just go to the chart studies moving average spot, and there's like exponential, here's simple, you can add those without having to code them from scratch. But if you, for some reason, wanted to code them from scratch, come in here. And I guess the first thing we need to do is set up a way to get a sum of the time period number of bars of data that we want to take our average of. So before we even do that, we have to have the time period specified. We'll move this to an input later, and I like to do it by putting a to do here. I'll say move to an input later. But let's say our time period is going to be 3. So we're going to make an integer, and we're going to call it period, and we're going to set it to 3. So this is going to be used later when we're taking the average of these pieces of data. Now the next thing we need to do is actually loop over the last period number of bars. And how do we do that? Well, we got to set up a loop. So loop over the last period number of bars. When we're going to be doing that loop, one thing we're going to need to do is actually we need to be summing the values as we're looping over them. So we actually need a variable to hold the sum of all of the bars that we iterate over. So because prices are not integers, they're floats, they're decimals, we're going to create a float sum, and we're going to set it to 0, right? Because if this is our sum, at the start of bar 1, our sum is 0, and then let's just pretend this value is 10, this value is 11, and this value is 12. For NASDAQ, this would be what? 10,000, 11,000, 12,000. But, let's just pretend it's 10, 11, 12. As we iterate over bar 1, we're going to say, hey, bar 1 is equal to 10, so we need to add 10 to our sum. So sum becomes 10. But then by the time we get to bar 2 is 11. We need to now add 11 to our sum. So now we're at what, 21? You see that sum is going to be keeping track as we add through, and then at the end we're going to divide by the time period, which, by the way, we had set to 3 in our example. So let's go back to our example here. So our sum currently is 0. Our period of time to iterate over is 3. So now we need to go ahead and loop. So I'm just going to set up a for loop here, okay? For, and then the structure of a for loop is you provide a couple pieces of information. For loops in C++ are very similar to for loops in most other languages. I'm gonna Adobo, if you can go on mute. You got some line noise coming across here, like sounds like a radio static. But if you look at other languages like JavaScript or yeah, that seemed to help. I think that's better. Yeah, I think that's better. So if you look at other languages, the for loop construction is very, very similar. So the first thing we're going to do is create an iterator to count over which number. I'm probably not saying this very cleanly. Let me just write it out. We're going to call it iterator I, and we're going to set it at 0. And we're going to say while that iterator is less than the number of the period that we're trying to go over, so we're going to put period, as long as our counter, which starts at 0, and as long as it's less than our period 3, we'll continue to increment our iterator. So this is going to just count, basically, it's going to go 0, 1, 2, and then when it hits 3, it's no longer going to be meeting this conditional condition because 3 is not less than 3. So it will then exit our for loop. And at that point, down here, we're going to divide our sum by our period. And then down here, we're going to graph it. So those are our next steps. So let's just use the closing price just to make it simple. And the closing price can be accessed through sc.close. And then we use an open bracket like that. That's actually accessing the closing price of the ith bar on the chart. So this is where I need to open up. Let me just open up a new chart book here. New intraday chart, and then I think I have the NQ. Let me just move this over here like this. Okay, so this is a 1 minute. Yeah, we can leave it at a 1 minute. This is fine. But let's move it to NQ just because that's the instrument that you are working on, and we don't need this many days worth of data. We can use 2 days worth of data, and we don't need 30. Okay. By starting our loop at 0, what we're actually doing is we're starting on the very leftmost bar on the chart. So if the chart has, I don't know, 1,000 bars or 100 bars, bar 0, according to Sierra, is the very, very first one, the leftmost one at the very left edge of the chart. The bar on the far right edge, the hard right edge, is we don't actually know what the number is right now. We can find out, but here's a way to think about it. If this is a line, and this is the leftmost edge, and this is the hard right edge, this is bar 0, and this is bar array size -1. Sierra chart has a variable called array size, and it stores the number of bars that are displayed, rendered on the entire chart. So this could be 100, and then array size -1 would be 99th, the 99th bar. So what we actually want to do is not start at the 0 bar like we have in our code here, because we don't want to start on the far left side. We actually want to start on the rightmost side, right? We want to start over here on array size -1. So what we'll do is we'll utilize that array size -1 in a calculation. So instead of starting at 0 here and going 0, 1, 2, 3, we're going to start at sc.array size -1 minus I. And what is that going to do? Well, if there's let's pretend there's 100 bars in the entire chart that are drawn, rendered here, right? Let's just pretend this is 100. By saying, let's get the close of the array size -1 minus I, well, I is what? At first, I is 0. So if I is 0, then the first bar we're going to be iterating over is 100 minus 0, which is the most recent bar. And then as I increments to 1, 100 minus 1 is 99. So that's the second most recent bar. And then 2 would be the third most recent bar, then the fourth and the fifth. And you see how we can step backwards now? You see how that allows us to keep moving backwards from the end, from the right side, basically? So that's what we're going to do. So there's us grabbing, but what are we doing with it? Absolutely nothing right now. We need to add it to our sum. So let's go ahead and say sum plus equals whatever the closing price is of the last 3 bars. Okay? And what we're going to do then is we're going to need to actually declare a variable to hold our average, which will also be a decimal. So we need to say float average, and it's going to equal the sum divided by the period. And then we just need to graph it. And before we graph it, what I'm going to do is I'm actually going to spit it out to the message log, and I recommend you do that as well. So I'm going to create an SC string object called message, and I'm going to say message.format, and I'm going to say our sum is equal to this number, and our average is equal to that number. And then I'm just going to put sum and average in there, and then I'm going to say at sc.add message to log, which will basically spit out dump to message log. It's going to go ahead and print out to the message log this string, and everywhere where there's a %f on this first one, it's going to put the value of sum into this %f, and on the second one, it's going to put the value of average into this %f. The reason is because this is the first one, %f, this is the second one, this is a comma, and this is the first argument that will go and get placed into this first one. This is the second argument, which will get placed in the second one. And so you can do this, you can have more and more and more arguments added here and other variables that get brought in. So let's, where's my Sierra? Here. I'm going to hit F4, which will bring up our advanced custom studies. So if you don't know, you can also go to analysis, build custom studies DLL, I have a shortcut here for F4. Just makes it easier for me to open. And then I'm going to select File, Coding Stream, C++, which is this file that we're writing here. I'm going to do a remote build by going build, remote build. I'm going to let it do its thing. And while that is compiling, I'm going to come back to the comments on the channel. Mock testing, Vim mastery. How long have you been coding? For over 35 years. Mediterranean fly, fruit fly. Luke, can't talk right now. Might be able a little bit. Location, I'll put the question here if you get to it. Add line until future intersection. Yeah, we can take a look at that. Next, and then Capcom can't attend. The voice phone data signal too weak. I started this code, doesn't work. Yes, you were the one from yesterday, I believe. So we'll take a look at that one as well. I'll take a look at yours first because I know you were there yesterday asking about this. Okay, so we can see that the remote build succeeded. If this doesn't succeed, it will throw an error. So like, for example, if you had a typo, like this is a typo, and then you tried to build that, it's going to die because the C++ compiler has absolutely no idea what this is. And you can see the error, the error here. This is not declared in the scope. In other words, the compiler has no idea what you're trying to do here. This is a typo. No idea what this is. It looks like we have another error here. Message not declared in the scope. Did I? What line was that? Line 33. SC string message. It's probably because of this typo. So let's remove this and compile it again. That silly text that I threw in there just to make the demonstration of a failed compile. Okay, there we go. Build succeeded. So now we've built our custom study. We have successfully compiled it, and now we can go ahead and add it to the chart. So let's go to Analysis, Studies. You can also use F6, Add Custom Study, and then we're going to look for, what's our name? Coding Stream. 2023-512 Coding Stream. Let's just, oh, there it is. Right there. So you see how this file name is right here? Like named DLL name. You see that? How that shows up right there. And then our graph name is this. Shows up right there. You can have multiple studies inside of one file. So you could have coding stream 2, coding stream 3. You can have them called whatever. You can call this banana if you want. It doesn't matter as long as it's not the same function name as this. But if you had more, then you'd have multiples sitting in this one DLL file. Okay. Let's undo. I don't need this other one. Let's go ahead and add. Here's our coding stream. We have no inputs, and I'm just going to hit OK, and it's right there. And then let's go ahead and take a look at our message log. Let's take a look at our message log. So on every single tick that's coming in, our study is getting called. Remember, Sierra is going to call our function once we add this study to the chart. It's going to call it on each incoming tick. And what is it doing? Well, it's calculating the average of the last 3 closes based on the time interval on my chart. So the sum right now is 40,000 something, and the average is 13,420. Now let's go ahead and take a peek at the chart just to eyeball that. 13,420. Let's go to the end of the chart. 13,420 for the last 3 bars. Well, where's the close of this bar? Up here. And then the close of this bar is here, and the close of the current bar is right there. Yeah, that looks like it'd be about 13,420. So that's our moving average. So we've calculated it, right? We've calculated it. If we want to change our period from a 3 to a 30, we could do it here, but at this point it makes sense to actually make an input where we could actually change the value of the period without having to recompile our code each time. We can just reference the input in the settings. So how do we do that? There's a variable called, it's called an SC, I think it's called SC input reference, I believe. I might have to check the documentation. I don't remember off the top of my head. Basically, an SC input reference. I like to preface my inputs with I underscore, just because it's visually easier for me to identify inputs in the code later. And I'm going to say period. And this is going to be equal to sc.input 0. This is our inputs section. So we have declared this input for the period, but we need to set some defaults for it. So inside of our defaults code block here, I'm going to say I period dot name is equal to period for moving average. And then I'm going to say I period dot set integer to 3, which is setting the default value of that integer for the period to the value of 3. And then instead of using period hard-coded to 3, you see I have my to-do here, I say move to an input later, I'm going to say no, use I period dot get integer, and that's a function call, to grab the value of whatever the period is currently set to in the input settings. So let's go ahead and try to compile that and see if I got that function name correctly. Let's take a look here. That did compile successfully. Now, here's one gotcha with Sierra. When you make changes to the defaults code block, you need to unload the study or the chart book. You can't just refresh the screen when you make changes to the set defaults. I'm going to go ahead and just save this chart book, and I'm going to call it coding stream 5/12/2023.cht, and just in case we crash later, and I'm just going to go ahead and remove this coding stream, and then I'm going to add it right back. So add custom study, coding stream, and hey, look what we got now. Where's our input? So we declared this input here. It's the first input, and then here we gave it a name inside the defaults block, and the name is period for moving average. Where does that show up? Right here. We gave it a default value of the integer 3. Where does that show up? Right there. Okay, cool. But what about our message log? Do we still have it calculating correctly? Yeah, it is calculating correctly still. Well, what happens if we change this from a 3 to a 30? Will it change the value? Oh, yes, it did. Look at that. Now we're down here. And our sum is drastically higher because instead of summing 3 bars worth of closing prices on the NQ, we're summing 30. So we have about 10 times. We had, what did we have? 40,000 earlier. Now we have 400,000. Well, now we have 400,000, and the sum is coming out to right there. So I think the last piece of this whole thing, and then we'll move on to someone else's question, is, well, this is great, but this is in a message log. I want to see it draw something pretty on the chart. Okay, let's make a subgraph. First, we need to declare a subgraph. Up here, we declared an input. Let's make a section up here for subgraphs. And I believe it's SC subgraph reference. And I like to preface my subgraphs similarly to my inputs that have I for input. I like to go S, and I'll just say average equals sc.subgraph 0. That just visually tells me It's a subgraph. Similarly to the input, we need to actually declare some basic definitions and things about the subgraph. So let's go ahead and say saverage.name. We'll call the subgraph the moving average. And since it's Adobo, I'm going to put your name in here. And what other things can we set on a subgraph? You can set a lot of different things, including like the color, the line style. You can set it to dotted dash line right off the bat. You can set all sorts of metadata. This isn't really about that, so I'm just going to say saverage name. And then all we need to do here to graph it is say, hey, saverage, take whatever bar we're on right now. So sc.index tells us what the bar number is that we're currently calculating, and set the average to be stored into the array of the subgraph that represents this bar. Okay? Store the average we just calculated over the last 3 bars into this current bar's value on the subgraph. That will make it appear in the subgraph. So similarly, we just added and changed something in the default section. What do we need to do? We compiled our code. Now we need to go ahead and unload our study because we made a change to that one section. So I'm going to remove this. I'm going to add it back. F6, custom study, coding stream, add. Let's take a peek at our subgraph section. It used to be empty, but now we've added Adobo FX moving average, which shows up right here. Okay. That was the only thing we set on it was the name. It defaults to a line solid and a width of 1, which you can customize here, or if you want to, you can actually specify those things here as well. But okay. So where is? Yeah, go ahead. What's up? Yeah. Yes, yes. So the question is our study function called on every tick? And uh, the answer is yes, with an asterisk. I was speaking to the founder of Sierra Chart about this very question. Is the custom study called on every tick? And the answer is yes, with an asterisk. It's yes and no. There's a couple of this is actually a really interesting question, and it's something that I've had to deal with in some of the work I've done for some clients, because some of those clients need studies called on every tick. The caveat to this is it depends on the pace of the instrument at that time. And it depends on your settings in Sierra in terms of whether your intraday unit storage is set to one tick in Sierra. So if you have that set to 1 tick, and then there's also a variable in ACSIL called I think it's like always update. It might be update always or always update. I always forget. It's one of these two. It's either always update or update always. Um, and what this does is yet a third thing. So I think the way that it works internally on the Sierra side that the application actually does is first it defaults to the slowest method you have there, which is usually your chart refresh rate. So if we go to Sierra and I hit F5, also, by the way, look at our moving average start to build out here as we were talking. Um, what section is it under performance? Yeah. You see this chart redraw time here? There is somewhere where you can actually specify this, though. Is it under display? Yeah, chart update interval. Okay, you see this chart update interval in milliseconds, and 0 uses the global setting, which you go to go to global settings, chart update interval, and set it for every chart. Sierra will, at first, at minimum, update and call your study at the rate that this interval is set to. So if this interval was set to 500 milliseconds, or half of 1 second, the slowest that your study would get called, the very slowest, the worst case scenario, if you will, is every 500 milliseconds, um, if that was what you had. You can do other modifications to the code, like setting this always update, and then also setting the tick intraday time storage to tick, which Sierra will then attempt to, not guaranteed to, but will attempt to call the study on every tick. However, that's not always feasible. And once, based on my conversation with him, my understanding is once the study, which if we go to studies here, you see how it has this studies to graph, the name of it, and then this 0 milliseconds right here? You see that? 0 milliseconds? That's the amount of time it takes for Sierra to execute this study on one pass. So like as one tick comes through from start to end of the code block, from here to here, it takes roughly 0 milliseconds for Sierra to execute this. Once you are trying to execute your study faster than whatever this is, say this wasn't 0 milliseconds, but say it was 500. Once you start having a study that's so big, so time consuming, so, quote unquote, expensive in terms of time, that it can't be run within the confines of the chart refresh rate, Sierra will start throttling the calls to that study. Yes, I think I can go on and talk for another hour or two just on this topic alone, which will really throw off like the rest of the coding stream. But this is a very, very important, especially if you're building out systems. This is a very important uh, thing to know and understand, that you might get throttled if your study is taking longer. So if you need to have something run on every tick, you have to kind of keep track of multiple different things. Yeah, you had a follow up? Auto loop? Yeah, so is the question, what does auto loop do? Yeah, that's also a good question. So auto loop, well, I'll start it with two ways. Auto loop is kind of a helper for beginning coders, I think, because once you try to do more advanced stuff, you really need to understand and control all of your looping by yourself. So auto looping is good for people who are starting out, who may not be getting all the data that they thought they would be expecting to get. But then if they turn auto loop to true, or set it to 1, which is equivalent to true, if you set auto loop to 1, all of a sudden they're getting that data calculated. That's because while they were on auto loop 0, or manual looping, they were not taking consideration for all of the different scenarios that they needed in order to have their code get executed. So with that being said, this is kind of a cheat for beginning coders. Once you start building more complex stuff, you're probably going to want to turn auto loop off. I, for example, always have auto loop off. I always have it at 0. I want to control, I don't want Sierra overriding any of my looping. I want to control all of my looping explicitly. Um, Not only because it provides performance enhancements, because I don't need to loop over stuff that I don't need to loop over, even if Sierra thinks I want to loop over it and I don't. And also, it's the difference between being precision, surgically precise with a scalpel versus using a sledgehammer. Um, when if you're trying to sew a small garment and you're trying to use have winter gloves on versus using your bare hands. It's that kind of approach. So, what auto loop does is Sierra basically tries to figure out what the data is that you need, that you're referencing, in order to loop over it. So it takes care of figuring out what data to loop over to make your study function. It's not always right. I haven't played with it an awful ton. I've seen it work for people who didn't set up manual looping correctly and didn't iterate over their structures or their data arrays, and auto loop took care of that for them. But I don't I don't use it, so I don't know if that's a good answer. I prefer to have all of my looping done manually so that I know exactly. Like for example, this I know exactly I know exactly what I'm looping over. I explicitly wrote what I'm looping over, and I don't want any other looping going on. With auto loop on, you can still provide your own loops, but you're not guaranteed for the overall study to be confined to the loop that it is. Oh gosh, how do I even explain this? With auto loop on, this is still going to run, yes. However, it may run more times than necessary. It'll be more expensive from a calculation standpoint. Not guaranteed, but it can run more times than necessary. With auto loop off, this is only going to run when you tell it to run. You control everything. So that's why I prefer manual looping. But I want to that those are two very good questions, Fab. To get back to Adobo on and finish off his question here, Adobo, you can see your average is updating while we've been chatting here, and it's been a couple of minutes, and you see all the values have been plotting. And why are they plotting? Well, they're plotting because we've gone ahead and we've said for every bar, take whatever that calculated average that we built from looping over the whatever the last 3 bars are. So, and we're on the last tick, right? So it's each incoming tick. It's adjusting this. See how it wiggles? See, it's wiggling around because on each tick, it's recalculating the spot of that average and updating it into here. As each tick comes in, it's saying, hey, grab the last 3, calculate the latest average. Now it's here, right? So that's why that's happening. But that's your moving average right there. Let me just can I do this in here? No. Um, Adobo moving average code. There you go. Okay. We had Luke, we had Capcom. I'm gonna get to Capcom first. Dave, hey man, what's up? Long time no talk. Hey Capcom. Yes. Yeah, yeah, I can hear you very, very well. Let's take a look at what you had here. You had a piece of code. Okay, download 3 wicks. Let me download this and open it here, and then use my large font thing so that it's easier to see. So just give me a quick rundown of what Let me just read through this actually. I'm trying to identify a candle pattern on tick charts and then draw them as an extended rectangle across the screen until future candles fully interrupt the rectangle. Um, the pattern is three or more consecutive candles where the wicks are larger at the top and they are than they are on the bottom, or vice versa. So basically, like a asymmetrical drawing rectangles, transparency settings. Okay, and then when you say tick chart, you want to draw a candle pattern on a tick chart. What do you mean by that? Just what do you what does that mean? Oh, a volume-based chart. So instead of a 1 minute time-based chart, no, not a volume-based, a trade-based chart. You want to say 1000 V, or not V, T. I think I typed in an extra zero. Here's 10,000 trades on the NQ. What's your instrument? Your preferred instrument? Okay, let's load ES so that you're on your home turf. And then what's the typical? You wanted 1,000 tick or 1000T. By the way, you guys, I've noticed a lot of people I speak to aren't aware of this feature. In Sierra, if you click in the chart and then you type, you can change the symbol in here. You don't have to go to find symbol. If I want to switch to NQ, I don't even have to type the whole symbol out. All I type is NQM and it switches there. ESM, it switches to there. I'm just typing and hitting enter inside the chart. And if I want to set, instead of 1,000 ticks, 1,000 trades, I want to do it 5,000, I just type 500T and hit enter, and there you go. Oh, I missed a zero. There's 500 trades. If I want it to be 5 minute, I just type 5M, 5 minute, 10M, 10 minute, 30M, 30 minute, daily. That didn't work. It switched to dash. There's a setting called, oh geez. It's is it? It's called like quick switch or something. Geez. Quick. I'll find it. I'll find it and post it. You have to be clicked into the chart, but then you can use those keyboard shortcuts, and it's really way faster. Um, may I make a remark about the tick charts once you're finished? Number. Hey man, long time no talk. Are you in here? Yeah, you are. Hey man, how are you? I'm all right. What did you want to say about tick charts? Mm-hmm. Yeah, and it would depend on your start and end dates and your chart settings too, right? Because if you started if you change your session time to be 9:31, you're all of a sudden missing that first 1 minute of ticks, if you will. So your bars will be drawn completely different. Good call out. Correct. Yeah, yeah. Okay, yeah. I'll just type 1M, and these will always be drawn the same way, even if you look back in 10 years. So, first thing I want to do is read through what we have in this code file that you provided us, because I've never seen this code before, and I have no idea what's in here. So I'm just going to narrate this as I read it through, and everybody who's watching can kind of walk through it with me. So at the top here, we've got our Sierra chart.h include. This is what gives us access to all the Sierra chart functionality in our code. The DLL name is going to be extended rectangle study. Here's the function declaration. Looks like we have an input. There's one input, and it's called number of days. And then here we have our set defaults code block. This is where all the defaults for the study are going to be set. The study is going to be called extended rectangle. It's got a description here. We've got auto loop turned on. Auto loop is on. We've got this free DLL set to false or 0. We can go into discussion of what that is. This is kind of for development purposes. It just makes it um, easier to develop things with respect to having Sierra release its lock on the actual DLL file that is being compiled and then hooked into the platform. So we can return to that. It's not really important for this. And then here's this input number of days is being given a default name, number of days, an integer value of 3 as a default, and then this one is actually setting a barrier, a limit on what the person who is modifying the input can do. So this input number of days, as you notice, can't go less than 1. Here's the limit. The lower limit is 1. This is the floor, if you will. And then the ceiling is this thing called int max, which I'm guessing is a Sierra chart um, constant variable, which is defined at. Actually, let's go look at it. You know, I'm gonna just split my screen here, go into Sierra chart.h. Can't find Sierra chart.h in path. Oh, is it because I know why? Um, let's open C colon Sierra chart ACS source SC constants dot H, I think. And then where is that input max? Is it in this file? It's not. Oh wow. Int max is not in this file. Huh. Is it in Sierra chart.h? No, it's not. Is it in here? No, it's not. Interesting. I don't know where that. Oh, it's referred to in here in intraday record.h, but not defined. Interesting. So I actually don't know where that's defined, but um, maybe it's not even a Sierra thing. Maybe it's a C++ thing. I don't know, but whatever. This is probably the maximum size that an integer can be represented for this architecture. Um, so you can't have more than that as a value here. Anyways, those are the defaults for the input number of days. We get out of our defaults code block, and here's the start of the study. We have an integer declared. We have an integer declared called bar index, and that's the same as sc.index. That's going to be the bar number that is currently being evaluated by Sierra chart. So in this case on the ES here, it'd be this most recent bar. We have a variable called number of days. It's of type int, and it is actually just referencing the input and bringing it into a local integer here rather than having to call the input.getInt function every single time you need to use that value. And then here we have a for loop, which looks like it's going starting at whatever the bar index is, and as long as it is greater than or equal to the number of days that were specified in the input, we decrement our counter. So we're starting at the end essentially and going back 1. And as long as we're above the number of days, we're good. So if number of days, what did you have it at? 3, I think was the default. Yeah, 3. So if this was a daily chart, it would go back 3 bars. So this may not be the correct naming of this variable because this is time. This variable name, number of days, is actually time sensitive, not time agnostic. So if you change the bar period to 1 minute, this is actually number of minutes. A more accurate name for this variable would be number of bars. But I digress. So we're starting at the end and we're working backwards. Um, so we're working backwards. We have declared a decimal called body, and it is equal to 0. We've declared a decimal called upper wick. It is initialized to 0. And then we have a decimal called lower wick. It's also initialized to 0. We have a Boolean that's a true false called is upper wick longer. It's defaulted to true. And we have a Boolean called is lower wick longer. It's also defaulted to true. So we have a couple things set up at the very top of our loop um, that happen right away, right away at the very first pass through this latest I, if you will. And then we jump into a second loop. There's a nested for loop in here. It's using an iterator called J. This one's on I, this one's J. J starts at 0, and it goes until it's less than the number of days or number of bars, which is 3. So this one starts at the very end and goes, 100, 99, 98. This one starts at 0 and goes 0, 1, 2, 3, etc. And then J increments by 1 through each pass. And inside this nested loop, we take our body, which is 0, and we take the absolute value. Absolute value will return a positive number for any number you pass into it. And the F at the beginning tells us that this is a decimal version, a float version of absolute value. So anything you put in here, if it's a float, will be able to be calculated by this. So typing is very important in C++. If you try to use absolute value like this on floats, you're going to get an integer back, not a decimal. You need to use fabs in order to get the decimal, the float value back of this. We won't dive into that right now, but you can Google fabs versus abs. Maybe if you Google this, you'll find out something about fabulous abs. I don't know. Upper wick. But what is this actually doing? It's taking the close of the ith bar, so that's the bar index, so like 100, minus whatever one we're on here, 0. So it's basically, at first, it's on this bar, we're taking this bar's close, and we're subtracting from it the open of the same bar. Basically, we're taking the most recent bar and we're taking the close, and then we're subtracting the open from it. That's the size of the body. So you're basically calculating the body. Here we're doing the upper wick, and here we have a function called max. Max is a math function in C++ that you can provide 2 values to, and it will return whichever one is greater. So if you give max 0 and 100, it will return 100. If you give it 100 and a million, it will return 1 million. So if you give it the open value and the close value, it'll return whatever one of them is the greater one. Okay. And then the same for the lower wick, slightly different. We're using min, which you can probably guess is the opposite of max. If you give it 0 and 100, it will give you 0 rather than 100. And then basically here are our 2 booleans. that we declared here, and they were defaulted to true. And basically, they will be set to whatever the prior value of this was, which starts off as true, as long as it is also the case that the upper wick is greater than the body. So if that upper wick is a greater value, is bigger essentially than the body that we calculated, this part becomes true. And as long as this stays true, that means that this side and this side are both true, which sets this to true. It's like a multi-part conditional assignment happening here. And then here, if either the upper or lower wick are true, draw a highlighted rectangle, and that's it. So that's what this code, I just walked through the code, taking probably way too long, but so what's happening with this? Well, I'd take a drink of coffee and cough my lungs out. What's going on with this? What's not working? Gotcha, gotcha. Okay, yeah, this is that makes sense based on what I'm seeing here. Um, so let's go back to the drawing board. I think one of the most important things is to have as we were talking with Adobo earlier, the concept of what you're trying to do. So how about ignoring the code? What in words described? I'm going to paint what you're trying to do. So in words, describe to me what you're trying to see. Okay, so if so you'd want your rectangle to be like this, basically, extending into the future. Okay, okay. Um, sure, sure. Let's break the problem up into smaller chunks. Um, and then we're gonna approach it from a slightly different angle. I'll show you how I'll approach a problem like this. So the first thing we need to do is understand, do these candles have to be consecutive? Well, either they do or they don't. Okay, so rule number one, uh, consecutive candles. And we're talking about 3 consecutive candles. Okay, 3 or more. Rule number two, you said at the beginning, let's disregard the body, but it sounds like the body is important because you're comparing the wick size against the body size, right? That's how you're determining that it's a valid, like, so the wick has to be greater than the body, right? Okay. And what would the relationship need to be? So if the bottom, I'm going to play devil's advocate here on a candle like this, if the bottom wick is like that and the top wick is like that, that constitutes as okay. Okay. So even if the candle itself is like this, huge, and the bottom wick is like this, and the top wick is like this, you still want that to count? Okay. Okay. So the second rule is top wick greater than bottom wick. Okay. And then that's really the first thing that we need to build is how to detect that. The rest of the stuff will come after, like the drawing of the rectangle, the uh, intersection piece, all of that stuff, that'll come later. The first part is building out this guy right here. So what I'm going to do is I'm actually going to use my I'm going to use my coding stream one here, but I'm gonna leave period there. I'm going to remove subgraph. I'm going to remove all of this stuff, and we're just going to start from scratch, but with the period, because we're going to reuse the period for this number right here, the consecutive number of candles. Um, and I am going to make my SC string object up here of message, just because I use that all the time. So the first thing that we want to do is implement these rules. I am going to put them over here so I can see them. And then where's our Sierra? It's right there. Okay. So the first thing we need to do is detect 3 consecutive candles. How do we do that? Well, we have to loop. We have to loop. So let's go ahead and loop through last 3 candles for I equal to 0. I is less than sc dot, or actually not, I is less than period, I plus plus. And then since we want to start at the most recent one, we want to work backwards, right? So we want we want to work from the right edge, the hard right edge backwards, kind of like we were doing in the moving average case as well. But let's go ahead back here. And we need to actually do some calculations for top and bottom wicks as we go along as well. How do we want to set this up? So we need to do a calculation. What is the definition of a top wick? Definition of top wick. Well, a top wick of a candle is going to be decimal, and it's going to be equal to the high of the candle at this bar minus the, well, I guess it depends on if the bar is an opening or closing bar. So think about that. If this is the body and let's pretend this is a green up candle, right? So let's say this is an up candle. This is going to be the close, and then this is going to be the open, right? But if you have a red candle, it's going to be the opposite. So in our code, we can't just assume, because in this is the open, and this is the close. So while the wick, the high and the low, are the same. Uh, they are the same attribute, if you will, the same parameter. On an up candle or a down candle, the open and the close are actually opposite of one another. So before we can actually calculate what the wick is, we first need to determine if this is an up candle or a down candle. So I'm going to make a variable called top wick. I'm going to make a variable called bottom wick. And then I'm going to have to make a decision of, is this an up candle or a down candle? That's the very first thing we need to do. So I'll just say if the close of the current bar is greater than the open of the current bar, what does that mean? That means we have an up candle. Else, if the open of the current bar is greater than the close of the current bar, we have a down candle. And if we get into this else case, this is a flat doji shooting star. I don't even know. It's a no change candle. It's a flat no change candle. Right? You have three cases. You do have a possibility where a bar opens and it just never executes anything, or it just executes at one price for that time period and nothing else happens. That can also happen. That would be that case right there. So in the case where we have an up candle, the close is greater than the open. Let's go ahead and calculate what our top wick would be for that. So the top wick in that case is going to equal the high of that candle minus the close of the candle. Let's draw that out. High minus close for an up candle. So here's this top wick. That's the high. In order to calculate the size of this, I need to take the value, the price value of this high, and subtract the price value of the close. That gives me the size, or the value, the size of the wick, right? That's the top wick. High minus close. Similarly, for the bottom wick on an up candle, bottom wick is equal to the sc.open minus the sc.low. It's going to be the open minus the low, which is, wherever down here.
Okay.
Right? This is just conceptual, all just writing it down so that we can have pictures to reference and understand what we're doing. Because it's hard to keep stuff in your head when you're trying to build stuff out. So drawing it down, at least it helps me. Now for the down candle, these are going to be opposite, right? So for the down candle, the top wick is going to be the high minus the open, and this is going to be the close minus the low. That's going to give you the bottom wick on a down candle. Okay. So now we got to here. Now at this point, we have both top and bottom wick sizes. You know what else we can do? Is we can calculate the body size here as well, and it is simply going to be the fabulous abs of the close minus the open, which doesn't matter if it's top or bottom because it's going to take the fabs, the absolute value of it. Another way to do this, if you don't want to rely on fabs, you could just say body is equal to, on an up candle, is equal to the sc.close minus the sc.open. This is the same exact thing as up there, just putting it in a different place more explicitly. And this is the open minus the close on a down. So now we have body and both top and bottom wick sizes. Great. Now what? We've calculated our top and bottom wicks. We need to now do a comparison. Is the top wick greater than the bottom wick? Let's go back to our code. Is the top wick greater than the bottom wick? But we need to do this over 3 consecutive bars. So let's think about what that would mean. That means as I start on the rightmost edge, pretending this is the rightmost edge, if I determine that this is yes, this yes is a top wick that's larger than the bottom wick, I need to somehow save that state because the next loop I'm going to be on this bar, and if this one isn't, well, then it negates the whole thing for these 3. But if this one is, I need to remember that this one is and this one is, because the next bar I'm going to be over here. I need to remember that these 2 were truth or truthy. They did meet the criteria, and I need a way to keep track of all that. So let's think of a way we could do that. One way we could do that is by using a Boolean. And we want to put it outside of our for loop. We don't want it inside of our for loop, the definition of it, because if it's inside, it's going to get blown away on each consecutive loop as it loops bar to bar to bar to bar backward in time. So here, I'm going to, outside of our for loop at the top, I'm going to declare a Boolean, and I'm going to say, we can either have it be truthy from the start or falsy from the start, and then try to match some series of conditions that will allow us to proceed down to this point. So if we, how do we want to phrase this? I tend to like to look for explicit truthiness. That's the way I like to approach things. I don't like to default to truthiness. So I like to organize my code in a way where I have to explicitly prove, basically, I don't trust, don't trust, and also verify is the way I like to. Also, I just saw that Luda joined, so I have to put this in, just because every time I see his username, I have to put that on. Um, those of you who are not in the Discord chat have no idea what I'm talking about, but what was I talking about here? Okay, a way to keep track of our state here. I have a better idea, actually. Let's, instead of using a Boolean, let's use a counter, and we'll call it a wiki counter. And the idea here on our wiki counter is that every time we encounter a top wick that's bigger than the bottom wick, we'll add 1 to it. And then we go to the next bar. And if we encounter another one, we'll add 1 to it. And then we'll go to the next bar. And if we encounter another top wick that's bigger than the bottom wick, we'll add 1 to it. And when we're done going through all of our bars, if the wiki counter is equivalent to the period of consecutive candles, that means that we encountered a top wick that was bigger than the bottom wick on 3 consecutive candles, and therefore we have this condition be true. Do you follow what I'm you smell what I'm cooking there? Okay. So here's our wiki counter, right? So then at this point we're inside of our loop. We have the wick sizes. Is the top wick bigger than the bottom wick? So for this specific bar, is the top wick bigger than the bottom? Well, let's say if the top wick is greater than the bottom wick, then wiki counter, we will add 1. We'll say increment our counter for consecutive wicks, top wicks, that are larger than bottom wicks. Luda. Oh man. Okay, where are we? So here, So now we have this. So if we have our wiki counter end up being equivalent to period after we get through this entire thing, we know we have a truthy condition. So let's go ahead, and this is out. Now we're outside. This is, oops, end of our loop. Do we have period number of consecutive wicks? And basically we can say if wiki counter is equal to period, we have our truthy condition here. You see where I'm going with this? So now at this point, this is where you would want to start draw your rectangle. Hey, what if it's more than 3? Um, well, our period is setting our loop conditions. So we won't be. So let me think about that. If it's sure. So like if this was like this is what you're saying, right? That's what you're saying. Well, no, it's a good question. So since we're starting on the hard right edge, it's going to detect this, 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 and then it'll draw this rectangle. But before this most recent bar happened, it would have already drawn the rectangle here. And then this bar happened right here. So this would eventually then be the intersect. So it would kill the rectangle there in future. We haven't built that out yet, but it would essentially stop drawing the rectangle because this bar, after this bar came into existence, because remember, what if this is down here at first, and then the wick gets into here? And Capcom, I don't remember if you said it has to fully close this wick area or if it has to pierce it. Okay, so let's pretend it does this. Let's say there's a CPI number, and it did something like this. Then you would end up closing off your rectangle there, skill thriller, because it went through that range where that was. So because we're going forward in time, we're going forward in time. Uh, yeah, that can be coded. Yeah. Well, we're not there yet, but um, we can add that to our rules. Cor Correct. So it'd have to be a situation like that, basically, which would close it. Yep. I'm building a trading system for some folks that deals with a similar concept as this, not with Wix, but this type of interrupt, if you will. Okay, so where were we in our code? We got to here, and we haven't even compiled this or run it yet, and we don't really know um, if this works. What I want to do at this point is say something like, I want to dump something to the log just to see if we get here. And I want to say something like, on this index, we have 3 top wicks, and I want to put sc.index in here, and then say sc.add message to log And then let's go ahead over to Sierra and compile this. This is the same file as before. I just repurposed it. So we got errors. Let's take a look. So right away, this is the line number that the error is on, 29. So I'm just going to go to line 29. And the error says it has no idea what I is because I didn't declare it. And I look here, and they're absolutely right. I just said I equals 0, but C++ is a strongly typed language. It doesn't know what I is. I've never declared it earlier here. I need to say I is an integer. Let me save that and rebuild this. Build succeeded. Analysis, studies, F6, add custom study, coding stream, add. There's our thing. There's that. And we've got nothing. Nothing coming through. So what does that mean? Well, one thing is that means that we may not have encountered any top wicks, 3 consecutive, that were there. Let's try this. What if we make this 2? Oh, look what we get. Bar 2510 has 3 top wicks. And since this is running on every single tick, it keeps triggering this code over and over, which is why we see it hit line after line. So let me add another study here because I have no idea which one's 2510. And it's called bar numbering. And this thing, display every 1 bar. And, oh, am I not at the end of the chart? Why is this at 1134? What the heck? SC index is 2511, but there's only 1134 in the chart. That makes absolutely no sense. That makes absolutely no sense. Let me go back and look at these settings. Oh, it's restarting at the, I see. There we go. There's a setting in here that lets you restart it, restart the numbering at the beginning of a new day. And I misread the label of it. I had it backwards. I do not want it to reset at the start of a new day. I want the first bar on the very left of the chart to be 0. The one annoying thing about this study is that it starts at 1 rather than 0, even though this is the 0 bar. Sierra chart considers this bar the 0 bar, not the 1 bar. So when you're comparing these two, what Sierra says is 2512 is actually 2513 on this. This is the 25. This 2513 is this bar right here. But is this actually accurate? Do we have? Does 2513 actually have 2 top wicks that are larger? And I don't think so. No. The bottom wick here is larger, and the bottom wick here is larger. We have these two, which are accurate. These two look like, well, maybe not this, maybe this one. These two look like they might satisfy that, but not this last one, because the top wick here is definitely non-existent, and the bottom wick is, and same here. Here we moved to 2014, 2514, and now 2513. We have 3 top wicks, so something's amiss here. So let's go back to our code. Let's see what's going on. It thinks that we always have 3 here. And why would it think that? Ah, I see why. Before I tell you why, does anybody know why? You're in the right, you're pointing the right direction, but it doesn't have to do with formation. So where in here am I referencing bars? I'm referencing them here, 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 right? And what am I using to reference bars everywhere? I. And what is I equal right now on the first pass? 0. I forgot to add the piece that starts at the right-hand edge. So it is doing the calculation on this bar and this bar. And that is why it is saying, yes, those two are wiki. And then at the bottom, I'm spitting out whatever the most recent bar is. But it's actually using these two bars to do the calculation, not these bars. You see? So that's why the code did everything correctly. The study did exactly what I programmed it to do. It's just what I programmed it to do was completely wrong compared to what we were trying to do. So let's go in here and make the adjustment. Instead of starting at 0, I don't want to start at 0. And since I'm using I already in all these spots, I kind of want to reuse I here and set up my for loop declaration here to start at the right-hand hard right edge rather than start at the back. So what I'll do is I'll say I is actually equal to sc.arraySize minus 1. So I is going to start here on this one. And instead of saying as long as I is less than period, I'm going to say as long as I is greater than or equal to sc.arraySize minus the period minus 1. So as long as 2516 minus 3, as long as we're there, actually I need to get rid of that equal sign, don't I? As long as we're there, and within these last 3 bars, then we're okay. But then the last piece is I need to actually decrement, not increment, because I want to go backwards, right? I want to go 17, 16, 15, 14. I want to go backwards, not forwards. So let's take a look at what this looks like. Let me go ahead and pull this down and hit remote build. And then let's go ahead and hit refresh on our and nothing. Nothing. So nothing on the last 3. Interesting. And it's only going to be calculating the last 3. So unless this puts in a top wick that's the next 2 bars put in a top wick that's larger than the bottom wick, we won't see anything show up here. Let's see if that happens real time. We should see it real time if the top wicks are larger. I'm not used to talking this much. There absolutely is. That's the that's the next step. Yep. Yep. I'm just gonna let this try to close out just so we can see the example live. But then the next step is to have it loop over prior bars. I just want to see if this closes here with a big top wick here, and then the next one has a large top wick. Okay, so we got one there. That's one. So if this one ends up building a top wick that's taller than the bottom wick, we will start to see this start spitting out. So that looks equidistant right now. Can we get another bit of a top wick there? Oh, that was close. These never happen like live. Whenever I'm waiting for conditions to like replicate live. Look at that. It briefly occurred right there. Boom. You guys see that? Sure. So other other filtering logic that you'd want to put in, right? Yeah. So that's something that you could add after you've calculated the wicks. You could add further filtering logic goes here into this spot, and then you could prevent your wiki counter. Like if that condition happened, you could prevent it from adding to the wiki counter in that situation. This is a proof of concept we're doing just so that everyone can see. So we know that it is properly detecting. So now the next step is, well, I want it to detect on everything. How do we do that? Well, there's a couple different approaches here. Basically, I'm just keeping an eye on the clock. We've been going for almost 2 hours here. Um, Basically, if this is your timeline of bars on your chart, and this is 0 bar, and this is sc dot array size minus 1 bar, when you load, recalc, or refresh your chart, Sierra chart will start right there. When you are live, Sierra chart is right there. So when we're live right now, unless we turn auto looping on and we're explicitly accessing the 0 bar, and remember we talked about auto looping earlier in the session, and I said it's kind of a cheat because you're not actually taking care of your manual looping. You're not controlling everything that's happening. Um, or maybe I'm just a control freak, but basically, this is only getting executed on this most recent bar, and that's it. Right now, this study is only being executed on this most recent bar. Sierra is getting a new tick into the ES. It's calling my function here. It's calling our coding stream function here, and it is only executing right here. In order to execute from the beginning, we need to do one of these three things and do here. Why do we need to execute from the beginning? Well, we kind of wanted to see if we had any other 3-tick situations happen between 0 and sc.arraySize minus 1. So I guess there's two things we need to do. One, we need to be able to visually see when we actually have one of those situations. So I'm going to add a subgraph up here, sc subgraph ref, and I'm going to call it wicks, or yeah, wicks, sc.subgraph 0, and I'm just going to give it a quick name. swicks.name is equal to 3 wicks found. And every time we get a 3-wick situation here, I'm going to add swicks, sc.index. I'm going to set it to, let's just set it to 1. It'll just be a true and false thing. It'll just be either on or off. So that is actually store instance of 3 wicks being encountered onto this subgraph for visual purposes and historical purposes. So that's one thing. The second thing we need to do is, going back to this drawing, what we want to do is when we have a reload or a fresh load or a recalc, we actually want to run through everything that's on the chart in order to generate all of those different 3-wick values that we saw from the whole time. So how do we do that? Well, come into here and we say if sc.index is equal to 0, this is a reload recalc situation. And then what we want to do is basically run through all of this logic right here for every single bar between 0 and the end. So how can we kind of I don't want to take this whole code. I could just take this and copy paste it into this code block. I could, and then modify it to be able to do that. But I want something that's a little bit more elegant. I want something that knows that it needs to, I don't want to have duplication of code. I only want one spot where I'm doing all these calculations, because then if I need to update something, I have to update it in multiple spots. It just gets messy, right? I kind of want one spot where everything can, all the magic can happen, and then some kind of switch or indicator or some kind of way to have my study detect when it's a reload situation so that we can handle this case and calculating everything that's going to be happening in here versus a situation where we're just live and we're only calculating on the last bar. How can we do that? Well, I know that if SC equals 0, we have a recalc, and then I know I need to start my iterations through everything. So what if instead of having this loop be declared by starting at the end, I actually pulled out these variables here and I specified them based on the context. So if we're live, then let's say we want to start at sc.arraySize.1. So let me make some extra variables. Start index, end index, and so this is we're live. And if we're live, start index is equal to sc.arraySize minus 1, right? I want that to be this. So I'm going to replace this with start index, right? And when we're live, we're there. And when we're starting from a recalc, I actually want it to be 0, right? So when we're starting from scratch, I want to start calculating here. Oh, but we need to look back 3 periods, so it can't be 0. It has to be 0 plus period. So let's do that, just as a safety, because if we're on this first bar and we try to go backwards, we can't. So we have to be at least 0, 1, 2, 3, and now we can look back 3 bars without accessing a piece of data that doesn't exist there. That would be bad news bears. So we have that. Now what about end index? Well, is end index always the same? Are we always going to the end? Well, in the live case, yeah, we are always going to the end. End index is going to equal sc.arraySize minus 1 minus period. Right? So if we're at or is it actually going to be that? Yeah, it will be that. From when we're live at the very end, we want to be here minus 3 bars, and that's what we want to go through. When we're at the start, what do we want to loop through? We also want to loop through to the very end. We also want to loop through to the very end. But this is assuming we're going backwards, iterating through. I'm just talking myself through the problem because we're going forwards and backwards here. So if we're starting from 0, we'll start here at 3 or 4, and then we'll go backwards 3 and calculate it there. But then that won't actually get us through to the next bar. So it's almost like we need that second loop that you had in your original one, where we can loop through the outer layer and step through each time, but then also do the 3-bar look back. So that's what we need to do. This start and end index isn't actually for this part of the loop. This part of the loop is just doing the 3-bar iteration. We need a second loop to iterate through either the entirety or just the last bar. So let's make a second loop, and we're going to put this loop inside of it. So this is going to be for int j equals start index. J is less than end, or less than or equal to end index, and then j plus plus. And inside of that, we're going to take our entire piece of code and put it right in there. So now, this is our outer bar traversing loop. So when we're doing a recalc, we're going to start at 0 bar plus the period, and we are going to go until the very end. End index is going to be sc.array size -1. If we're live, we want to start on the very last bar. We don't want to start at 0. We want to start right here. And we go, an end index is actually equal to the start index. We want to start and end on the same bar when we're live. When we're live, we want to just loop through the same exact bar. And it's going to just be the most recent one. When we're refreshing, we want to loop through the very first one. So that's our outer loop. So here on a live bar, we're going to start on 2531, which is this most recent bar, and we're going to end on 2531. And that's it. And we're going to loop through the last 3 things. We need to adjust this. So this can't be this. This I starts at, what are these going to be? I need to rethink what these are going to be. I is actually going to be j here. It's going to use what the start index is, and as long as I is greater than j minus period I minus minus. So let's walk through. On the last bar, I is going to be 2532, which means this will be 2532. And as long as I is greater than 2532 which minus 3, which is 2529, as long as I is greater than 2529, then decrement as you're adding to it, which is exactly what we want. Now let's take a look at the 0 bar situation. If we're at 0, I is going to be, actually it's 0 plus 3, so we'll be at 3. So we're going to start at 3, and as long as I is greater than 3 minus 3, which is 0, decrement. Yep, that's exactly what we want. And then I will be used for all our calculations here. Okay. If none of that made sense, I know I'm going kind of quickly, but I'm getting fatigued here, and probably need to wrap this up soon. But how many people we have in here? Oh my goodness, that grew. Hey everybody. Okay, let's. Where are we? Where are we? Let's get this to a nice stopping point. So we don't want to use SC index here because we're going to be in this big outer loop. We want to actually use J instead of SC index. Likewise, J here. So now, if we compile this, we should. Actually, we made changes to our defaults because we added that subgraph, so we need to remove this from here. And then let's go ahead and add it. F6, add custom study, coding stream, add. Let's double check. There's our 3 wicks found line. And it should be between 1 and 0, right? That was our, do we have any? We have nothing here. Let's see if we hit refresh. Nothing. Oh, that's not entirely true, actually. It looks like on bar 5, which is actually bar 6 here, drawn, it says that we had 3 top wicks, but that doesn't appear to be accurate. We have 1 here and 1 here, but not this one. I wonder if it's keeping track of this one from here, and actually I think it is, because our wiki counter, is it getting reset? No, it's not. We have to, you know what we have to do? We have to move our wiki counter into our loop right here, into our outer loop, because it needs to get reset as it traverses through each bar, otherwise it'll remember. So let's go ahead and recompile that. And let's see what we get now. Ooh, now we got a line right here. We got a line right here, and it is not clear what. Maybe instead of a line, we can use a point. It might be a little bit easier to see. A dot. How about a point? Let's use a large point. Aha. Okay. So I see an error here. This only had one, not three. So that's an issue. Right there. Or is this just a scaling issue? I can't seem to be able to modify the scale here on this. Range, reset, independent. I could just do independent, right? Or user defined. Scale settings, can I just set min and max user defined? 2 and 0, 2 and 0. There we go. Now we can see them clearly. So what about this one? 1, 2. Yeah, that looks good. 1 and 2. But 3, no, that's not right. Here, only this one is, and it's barely bigger than. So we have some erroneous looking data here. Let's take a look at these. That looks good. That looks good. And that looks like it might be good. So maybe right there. And then in our message log, what we have is the most recent bar. So let's go ahead to the very last bar. It's saying that the very the very last bar is qualifying for this, which, yes, that is true. Oh, no, it's not, because this wick is not, this top wick is not greater than the bottom wick. So we have some kind of bug in here that is erroneously identifying this type of candle as contributing to a top wick when it's actually, or it's not. This top wick is not greater than this bottom wick. So how do we figure that out? It looks like it is traversing through the entirety of the chart now, which is cool, and also doing it on the most recent one automatically as well. But with the wrong data, we don't have what we need. Let's try to figure out what's going on here and then fix it. So on 2537, we definitely have a valid top wick. Oh, you know what we can do, Capcom? Let's make a second. Let's make a second subgraph. We'll make it subgraph 1, and I'm going to switch this subgraph to be every time there is a top wick that is larger than the bottom wick, and then this subgraph will be when we have 3 wicks together. So I'm going to give consec wicks will be 3 wicks found, and then this will be top wick found. We'll do it that way. And so then where this says that, we're going to say consec wicks, and then where we have a top wick is greater than bottom wick, we're going to put s wicks I equals 1. And let's go ahead and see. So now we should have, I'm going to have to remove this because I made a change and added a subgraph. So that compiled, F6, add custom study, coding stream. I should have 2 now. I'm going to make them both points. One of them this color, and then the three wicks consecutive will be this one. And then let's go ahead and do our user-defined range of 2 to 0. And so when three wicks are found, it's going to be this color. When a top wick is greater than a bottom wick, it's going to be this color. So you have kind of like this stoplight system that appears to be developing. Um, so here it says the top wick is greater than the bottom wick, and I agree. Here it says the top wick is greater than the bottom wick, and I don't agree. Ah, but on a refresh, it's gone, which means that at some point during the duration of that bar forming, it did have a higher top wick than a bottom wick. But on the most recent, once the bar closed, it was no longer true. So it's almost like you have to recalc. You don't want to recalc on every single incoming tick because that's a ton of data to have to calculate over, especially if you have thousands of bars in every single in the chart. Then you have to iterate through those thousands and thousands of times for every single tick. That's probably why when you were looking at your code, you were getting some of that that freezing situation that happened. You're saying that Sierra froze because you're iterating over potentially thousands of bars over and over. But yeah, so this is not updating prior subgraph values based on bar close, which is you can there's actually quite a few different ways to handle this, and um, one of them would be wait till the bar closes and then go back and paint or add the value to the subgraph for the prior bar once it's closed. That's one approach. Another one is every interval of time or every time a new bar is added to the chart, do a full recalc of everything. Like if a new bar is added, just redo the calcs on everything and reset the variables. There's probably like 10 different ways to handle that specific problem. But I wonder if that's what. So yeah, that's correct right there. Is this a 3? 1, 2, 3. It's visually this looks inaccurate. 2536 to me looks inaccurate. This does not look like the top wick is greater than the bottom wick to me. Just 2536. Like when I zoom in on 2536, that top wick starts at 12525, 12475, 124. So what is that? Half a point up here and 3/4 of a point down here. So that's erroneous right there. That's wrong. So the question is why? Why does it think that 2536 is one of these? Why did it come in here and say, yeah, the top wick is greater than the bottom wick? Let's figure that out. Is the yeah. Mm. So, oh, really? Inherited. I don't think that should um yeah, because that's just the value format of the of the study itself, the output of the study format. Oh, Nick got it. Nick, you're absolutely right. You're right. I got myself. It's this one. It's this one. You're absolutely right, Nick. That's it. Bingo. You're the dude from New York. I haven't talked to you in a long time, right? Like we'd spoke. Okay, I was wondering. Someone asked where you went after we had or was it number? Number, are you still here? Somebody asked where you were like a couple months ago. I was like, I don't know. I never saw him again. So no, yeah, definitely. Yeah, yeah. I just saw this morning when I was putting this up. The last coding stream was in November, and I was like, wow, it's already May. But things have been busy. Ignore that you're solving a different problem. This is very educational. How often do you do these coding streams? I'm gonna start doing them. I'm gonna try to do them fly once a week on Fridays. Probably not 2 hours plus length, but I'm gonna try to do like half an hour on Fridays, um, just to chat and look at some code. Yeah, it's fun. It's fun. We used to do, well, I'm not going to go down memory lane, but Nick is absolutely correct. We have a case, and what I should have done, guys, is put to do here, and I didn't. We have this case here that is not implemented. So what's happening is um, we are falling into this case here, this code block. And yes, it is. This is recorded, and it's actually accidentally public on YouTube as well. So I don't even need to publish it because it's already being published right now and streaming live right now on YouTube. So yes, it'll be on the channel on the channel in the coding stream playlist or whatever. Um, so yeah, I missed implementing this one. So what do we do when we have a situation where there is a no change candle? What should the actual behavior be? Does a no change candle, like, do we just want to calculate if the top is bigger than the bottom? That seems like a logical, right? So if it's no change, then then let's just say we'll use the same rules as the up candle, right? I mean, it doesn't matter because if it's a no change candle, then it's the same rules. So let's go ahead and build that. Okay, let's go ahead and hit recalc. And now we see 2536 no longer qualifies for that. So kudos to Nick for the eagle eye on that one. And so now let's find, oh, there we go. Let's take a look. Yes, yes, and yes. This is true right here. What about this one? Yes, yes, and yes. That's true. What about this one? Yes, yes, and yes. That's true. What about this one? Yes, yes, and yes. Yes, this appears to be functioning correctly now. So each of the three, these all had 3 consecutive wicks go, and you can see very clearly by the stoplights where those are happening. So I think this is a pretty good stopping point. What you can do, Capcom, from here is that when you have I'll share this code with the group here. Okay, see you, Nick. Um, when you get this consec wicks value that you're getting set to true, this is where you want to draw your rectangle right here. So your rectangle drawing code would pop in right here. And your start index would be j minus period, right? So a rectangle start index would be j minus period. Rectangle end index would be sc dot array size minus 1. Your rectangle start price would be probably the high of the SC dot high of J minus period bars ago. And then your rectangle end price is going to be, I don't know, you might have to, it kind of depends on what the, you might have to add some additional logic, because if it's an up or a down candle, it'll make a difference. But for the start of it, you could just do something like just use the open or just use the close. You could just say like SC close of J minus period. And if you draw your rectangle using these parameters, it will start drawing them. Also, I would include a drawing line number that is associated and calculated by the bar index you're on, so that it redraws instead of adding new rectangles. So like in your, I don't know if you had this in this one, line style, line, you don't have a line number in here. So add a line number. It'll look like, oh geez, where did I go? Line number, and I would make it something like, like J. Like just, you might as well just make it the actual line number. And because that way it'll not keep adding. If you specify a calculated line number for that specific rectangle, it won't keep re-adding it every time you redraw. But let me share this with you guys here. And I'll say cap con code. There you go. Yeah, I hope that points you in the right direction. Yeah, so this went way over. This was two and a half hours basically. Next Friday, I'm gonna try to keep it closer to like half an hour, maybe 45 minutes. But just a space for us to draw stuff out, code stuff up, struggle together, watch me make typos, and understand how to build stuff in ACSIL. So hope that was helpful for you guys, and I'm going to go get some work done. Have a good, you're welcome, man. You're welcome. You're welcome. You're welcome. Have a good rest of your weekend, and I will catch you guys on the next one. And stream button is